A little bit of context on this is I've been working in a project with Django REST framework where I arrived, and it was a big project going on for a couple of years with many developers coming and going, and then you can imagine there's a lot of a mess. Everyone does everything separately, so I want to guide you a little bit about my journey trying to understand what's happening there and what do you need to do when you need to implement new features and you don't know where's happening things, because that's the thing with Django. You got a couple of lines and all of a sudden you have a complete API running. So what will we cover? A little bit of context of what's Django REST framework. I'm assuming that if you're here, you already knew a little bit of Django. I won't talk much about Django, but yeah, a little bit of introduction. And then I'll go to the specifics of Django REST framework. So serializers, API views, view sets, routers. And as I told you, it's a little bit of a walkthrough through the process of understanding what's happening behind the scenes, a little bit of what can you do to go deeper when you need to understand something. I also just will talk about what's happening behind the scenes. I won't talk about anything about architectural decisions, best practices. So maybe there are things that I show and you say, no, you shouldn't do that, but I won't enter into that discussion. So what's Django? Django, like going through the documentation you can read, is a high-level Python web framework that encourages rapid development and clean, pragmatic design. It's a library that offers you a whole bunch of things that you will need when building websites. It's very mature. It offers configuration, routing, ORMs, admin panel, a very nice admin panel, caching, authentication, authorization, among many other things. And then when web development started going through where it is today, where you got these modern frameworks working with JavaScript, then the server side needed something that was specific about APIs and just working with the data. So that's where we got Django REST framework to build REST APIs. It builds on top of Django. So Django REST framework is a powerful and flexible toolkit for building web APIs. It goes on top of Django, builds web browsable APIs so that you can have, as a developer, go to the different endpoints and see what's happening. Authentication policies, serialization. It offers the possibility of doing multiple HTTP verbs, etc. This is a little bit of how it interacts. So you got the client making the request to the server. You got Django as a big API, that's the server. The URL configuration takes you to Django REST framework, where it's the views, and then you interact with ORM and database. Like, this is a very simple diagram, but more or less that's how you can see it. So let's start with serializers. What's serializers? The basic is going for serializing data and deserializing data. So serializing is converting complex data types that you got in your application, complex Python objects. When working with Django, that would be usually Django models, but not necessarily. And deserialization, that's the other way around. You receive data from the outside, and you need to validate, parse it, and convert it into these application objects you have. Important thing, serializers are not in charge of parsing. The idea is that you parse whatever comes from the outside, and with that parsing that you will have like in Python native data types, that's what you put into the serializer. So let's see a little bit of the serialization process, because it's the simplest one. You got your complex application object. Let's say this complex class, that's a point. Everyone can see good the code? Well, I don't know. Yesterday there was a talk where I can see nothing, so let me know if it's too little. And so you can build this serializer. This serializer is designed to just give you a representation and a way of taking this class, this application object, into basic data types. In this case, float fields. How would you work with this? Then you instantiate your point. This point, you pass it into the serializer, and then you just call the data. And with the data, you can see you got a nice dictionary. Now, when you want to modify how this serialization goes, let's go with this example. Now you want to put it in polar coordinates. So with the same object, you have the point with x and y. Now you want this representation. So you got the r and theta, and instead you change the toRepresentation method. ToRepresentation method is where the magic happens. So as you can see before, we just called the data attribute, but the data behind the scenes calls the toRepresentation method. And in this case, well, here you can run all the calculations for converting from the x and y to the polar representation. And at the end, you got this nice serialization with the correct attributes. Serialization is just a straightforward process. The interesting things happens with deserialization because data coming from the outside is not trusted, so you need to do all validation. So how is the validation going? The basic process is like you receive the data, here it's already parsed. You pass the data to the serializer. Notice that now you need to put the data. You first need to call the isValid method. If you call the validated data before calling this valid, it will fail. So you call this valid, and here's where all the validation process occurs. And then you got the validated data. What happened here? So this is what happens when you call the isValid method. So first, it validates empty values. It sees what values are missing from your data that you have in the serializer, sees if you have default values for the missing points, and in case you don't have default and it's missing, if it is required. So if it is required, it fails. If not, then it's okay to go. Then it calls the toInternal value. toInternal value is like the method that really goes and does the deserialization, takes the data and starts processing and validating field by field. After the internal value, you get the, so you can define in the meta of the serializer some extra validators that work through all the data and they go afterwards. And finally, the validate method. The validate method, you can define it, you can override it, and it's for working with the data as a whole. It's the final steps, so you can assume that the data field by field has already been validated. So a little bit of the code execution, like to know what's happening. So I just created this validator that is a mess. It's just overriding every single method of the validation process and adding a print statement before running the validation and after the method. And with these print statements here and in the fields that I put there, you can see the execution. A little bit here in the execution, you can see it starts with this valid method, then it calls the run validation method, then the validate empty method, and then it starts with the internal value. In the internal value, you go through, like in this case, I just have two fields, the R and the theta, but in general, it iterates through all the fields and start running the validation process in each of the fields. So once again, run validation, validate empty values, to internal value of the field specifically, all the way through. Finally, after running the toInternal value, after it ends, it's the run validators. In this case, I didn't add any validators, so the validator list is empty. And the validate method as a final step. So this is what happens. This is where if you want to override something, for example, it was very common in this project to find the validation of the toInternal value, which is nice, but you got to be clear that if you override the toInternal value method, then you need to take into account all the validation of each of the fields. So it's important to know what's happening behind the scenes. And finally, there's the save method. The save method is where you take the validated data and turn it into a complex application object. Once again, usually it would be Django models. And what it does is, when you instantiate the serializer, you had passed also an instance of the complex object, it will run the update method. And in case you had not passed this instance, it would run the create method. The default implementation of the serializer has no implementation of update and create, so you need to add them if you want to, or you can override directly the save method. Now, model serializers, it's basically a serializer, but it infers the fields based on the Django model that you pass, and then it creates a default implementation of the update, create, and one delete method. These default implementations go through the manager of the model that you define and create it, update it, or delete it. But in general, all validation and everything works just like a serializer. It just adds these implementations here. And the list serializers also, when you are handling with list, you can pass an argument at the end when instantiating the serializer that's many true. What it does is that instead of creating a single serializer and taking the data, it assumes that you will pass a list with instances. So it basically creates a list where each of the instances is one of the individual objects, and each of the methods for validation and everything just iterate through each of the items and run the methods in the individual serializer. If you want to modify this, maybe performance, you prefer to bulk update instead of updating each and every one of those, you can add the list serializer class to the meta in the serializer. This will make it so that here you can point to another class that you want to use as the list serializer. So instead of implementing the default serializer, you would go to the one that you want, and you can then customize the behavior. Now, let's go a little bit to the API view. What's happening? So Django offers you, like Django REST framework, offers you two ways of doing it: function-based views with this decorator, and API view for doing class-based views. The API view decorator basically creates a class under the hood. So you have the function, and it creates an API view class in which the function that you're decorating will be the handler for all of the allowed HTTP methods. But then the behavior is exactly the same as the class, because that's what's happening behind the scenes. What's happening in the class? The class is a subclass of Django view, so like the interaction with the URL is the same, but then it has a dispatch method. What's happening in this dispatch method? So first, it's wrapping the HTTP request within a custom request object from Django REST framework that has more abilities of authentication and content negotiation. It allows you to have different formats. Then at the end, it returns response object instead of HTTP response. So it's also custom so that you can have many different, like new additions, especially with content negotiation and stuff like that. And error handling happens through this API exception, and it handles authentication, permission, and throttling. So a little bit of the difference between this function and class-based view. So when you have the function, you just add the decorator here. This comes from the documentation, this example. And then you need to check what's the method that's coming and run the logic according to the method. With the class view, what you do is a method per each of the methods. So you define what's happening in the get, what's happening in the post, and well, the dispatch handles the appropriate method whenever it needs. So what's happening when you do the request? Like I told you, first there's a request initialization. It's basically taking the Django HTTP request and turning it into a Django REST framework request. Then you got the initial method. This initial method is for anything that should happen before the actual handling of the request. So you got content negotiation, versioning, authentication, permission throttling. So in general, check, is this request permitted or not? Then it checks, okay, so the method of this request is this, and I look for what's the handler for this method. So what's the actual method for the put, post, get, etc. And it calls this handler. And finally, there's a finalized response, like where if something fails in the process, you just call the handle exception, where different exception handling happens for different errors that can occur. Notice that when there's a handling exception, usually you just not let everything fail, but you return a response with the appropriate error. And the finalized response just takes the request from REST framework and turn it into the actual Django HTTP response. So this is the dispatch. This comes directly from the source code of REST framework. So here's what I was telling you. First, the initialize request. Here you take the request from Django and turn it into a Django REST framework request. Then you got this initial method. I will show it in a minute. Then you look for the appropriate method within the class, which the HTTP method names, and you call it handling the request. And finally, you have like all this block within the tray where you can call the handle exception and the finalized response. This is the initial, because the initial does a lot of things. So format suffix, you can have the endpoint to have like the actual format that you need, so .json, for example. Then you have content negotiation when, depending on the headers and the suffix and everything, it decides, okay, what parser class do I need? What renderer do I need at the end? Versioning, it offers ways of versioning the API, determining what version does it need to handle. And finally, the authentication. Notice all of these methods can be overridden either directly or through a special policy, like this policy different attributes. Like you can add renderers and parsers. So like you can see in the initial method, it has methods for getting the renderers, methods for getting the parsers. So you can customize that with special attributes in the API view where you add them to a list. Also authentication, you can add authentication backend, permission backends. Everything is pluggable. Also classes for handling throttling and exception handling. You can modify all these methods. If you need to look for the specific method you need to modify, there's the documentation. And finally, mixins and generic views. So Django REST Framework also offers mixins and generic views. What's basically mixins? Well, it's a pattern that you can use in object-oriented programming, but Django REST Framework uses it for providing like common functionality of the API views, common CRUD operations, and the generic views are then composed with these mixins to offer like very standard views that you would usually use based on a model, a Django model, and you can have very lean views. I will show you some in a minute. So the generic view adds these things. So first, a query set, a base query set that you will use for the API. It adds a way of customizing the serializer class that you will use. The lookup field, so when you need a specific object within the query set, what's the field that you need to filter for? Usually it would be like primary key or ID or something like that. By default, it's primary key. There are pagination classes. It offers different ways of handling pagination of both the query set specifically and then the request, the response that you need to do with pagination, and filter backends. There's ways of handling filtering, very neat. Generic class is not usually used alone. Like generic class gives you all these different options, but it doesn't give you an actual implementation of the methods. You would still need to put the actual handlers. And that's where you got the other mixins and generic views so that you can compose them and you can get the actual handlers going there. So these are the mixins that come with Django REST Framework. These are the generic views that come. So create model mixin, list model mixin, retrieve, update, destroy, and the actual view. So create API view, all that, and combinations of these. Let's see the example of the same snippet code that I showed you before. So you have this generic view. The same, it does exactly the same that we saw before, but now you got that instead of inheriting from API view, it inherits from list create API view. You just define the query set, where is it coming, and the serializer class that you will use. What's happening behind the scenes? So, what's the list create API view? The list create API view basically calls these mixins, calls the generic API view, like inherits from them, and implements the methods. So, the get method will call the list, and the post will call the create. So now, where are the list and create coming from? The mixins. These are the create model mixin. Can you see it right? So create model mixin and list model mixin. It uses the different things that generic view gives you, the query set, the pagination, the filtering, and adds a create method, like generic create method and generic list method. Look, by themselves, the list, like you can use it, but it won't convert into an HTTP request. That's where here, it's the connection between the list method and the actual HTTP method happening. And well, then you can just go and combine everything here. Finally, you got the view sets. View sets are a way of combining common logic into a single class. So, for example, in the previous example with the views, we would need one view class that includes the like the list view with the like retrieving the list and creating a new one. But then if you want the detail, you need a new class because you cannot have two get handlers in the same API view. View sets are a way for having this. They combine related logic based on the actions. The logic is not specifically matched to an HTTP verb. The idea is that you have actions, so it's not exactly related. I don't have to define specifically a get method, a post method, but I define actions. So a little bit more of what I actually need in my view to happen. The magic, everything happens in the asView method. AsView is when you define the URL configuration. That's when you connect the actual HTTP verb with the action that you need to happen when the request is done. And well, this magic is enhanced by the routers. Django REST framework offers routers that does this connection between HTTP verbs and actions automatically for you. And you have different view sets. So there's just the view set that is like equivalent of the API view. It doesn't offer any action by default, and it doesn't have much things about query set and pagination and all this stuff. There's the generic view set. It basically inherits from the generic API view, so it offers all the same things: query set, pagination, filtering, and all this stuff. And then you can use the same mixins for this. Like we saw, the mixins just offer like this action, so list, create, and that's exactly what you need in the view sets. You don't need the actual HTTP verb, but just the action. So you can use the mixins for combining different things with the generic view set. And then what we had earlier, so with the previous snippet that I showed, I would need these two URLs. So the snippet list as view mapping to this URL, and then the detailed in which I had, this one I didn't show it, but where you have the detail implementation, the update, and all this stuff, mapping to the, well, to the specific primary key endpoint. With the view set, now I would define a single view set. It's pretty similar to the one that I showed you, but in the one that I showed you, I had two classes. Now I only need this one that defines the query set. It comes from a model view set that I will show it in a minute, and defines the serializer snippet. And now in the URL configuration, okay, well, first, the model view set. So the model view set that I'm inheriting from is basically inheriting from the generic view set here that adds the functionality, and then the actions come from the mixins that we saw before. Create model mixin, retrieve model mixin. So it has a create method, retrieve method, update method, partial update method, destroy. Now, with these methods, what do I need to do to actually map them to the HTTP endpoints? As I told you, the asView method is where the magic happens. So I can take the same view set and tell tell it, okay, so for the list URLs, I will map the get to the list action, the post to the create action, and so. And here I define the URLs, or as I told you, using the router. The router does exactly that for me. It matches like the default actions, the default CRUD actions to the actual HTTP verbs that you want in both levels. So detail level or generic level, so the list level. And the detail level just adds the primary key to the URL. And additionally, it provides, with this router, it provides, so you register the viewset as it's shown here. So I define the router, I register the viewset with the base name of the URL, and then I just call the URLs. So what's happening? I register the viewset, it generates the URLs for me automatically based on the default actions. It has detailed actions versus list actions that you can define, and you got custom actions that you can define with the action decorator, and the router automatically maps them to the correct URL. So now, if you want to dive deeper, go to the documentation. It's very complete, and you usually don't read it. I didn't read it, and now I found it has almost everything. Go to the source code. It's a very nice way to understand what's happening behind the scenes. Don't be afraid of the source code. Sometimes you see this big source code that you don't understand, but then you go to the serializer and you start seeing what happens behind the scenes, and your mind opens. Practice debugging. Open a debugger, put a stop somewhere you want, and start going in and see, okay, where is this happening when I run this request? And have fun. Build robust APIs, have fun with Django REST frameworks, with Django REST framework. Thank you very much.